Our second topic in the fundamentals of GIS, GLM 7106, is spatial paradigms, generally the nature of spatial data. Lydia Mazika Yondondandiko here to take you on once again. So in this lecture, we are going to look at modeling, field or raster-based data models, vector or object-based data models, and any other data models. So just look forward to how GIS manifests itself as far as its data is concerned. This course is planned to enable students to understand what modeling in GIS would look like, to differentiate between vector and raster data models, to experience the various data models used in GIS, and to know when best to use which data model. As I mentioned earlier, we shall have a mixture of lectures, case studies, tutorials, laboratory experiences. So keep tuned in. Let's do the lecture part of it, and we shall catch ourselves in the lab to have a feel of what we have theoretically covered today. So topic 1, modeling. We all know that the world is so much complex, and if one needed to represent it in a computer, it would be almost impossible. So all geospatial data are simply incomplete approximations of the real world. Models are the abstract representations of the real world in various forms. They can be pictures, they can be graphs, they can be sculptures, or name it. A model generally is a simplified representation of a system or a phenomena. In this case, a geographic phenomena, since we are talking about GIS. Modeling is a scientific activity, and the aim of modeling is to make a particular part or feature of the world easier to understand, define, quantify, visualize, or simulate. So the reason we model is so that we can create understandable situations, definitions, quantifications, visualizations, and simulations. In GIS modeling, we use a set of rules and procedures for representing a geographic phenomena or for predicting an outcome. The key word here is representation. We define a geographic phenomena in GIS as anything or something of interest that can be named or described. In this case, we have a road, a river, a building, the area that is next to the scientific library. So something that can be named or described, something that can be geo-referenced, meaning that you can assign real-world coordinates to that thing. And then something for which a time interval can be defined for it. Of course, when we start talking about time within a GIS, then we are talking about time series analysis, meaning that something can be named or described, it can be geo-referenced, but if the phenomena has no time interest, then the third attribute of the phenomena can be done away with. So we can identify with two conceptualizations of space. Field-based conceptualization of space and this is called raster data model, and object-based data model, which is a vector data model. So as you can see here, this is the real world. As you can see a house, you can see trees, you can see a road, and maybe a river of sorts. With field-based data modeling or raster data modeling, you can see that this geographical area is composed of pixels or tessellations of space. And with object data-based modeling, you can see that this geographical area has the house represented as a polygon, a box, has the trees also summed up together. These are the 3 trees, and that one tree just right there. I wish to say it again, that with this topic that we are handling, when we talk about vector-based or field-based data models, it is very difficult to talk about one and not the other. It is preferable that I keep speaking about them interchangeably, and the reason basically is for you, the participant or the learner or the student, to be able to grasp and try to differentiate them. They are a core foundation of appreciating data and how it is modeled within a GIS.